Hello students, welcome to maths class. Today we'll finish our limits topic, right? We did a lot of problems from the limits. Actually, we are going to get 3 or 4 2 marks questions from these limits. That's why we are doing. I think now you got the idea just by seeing the problem which method we have to go, right? There are totally 5 methods we are having, right? So in those 5 methods, substitution means direct substitution. If after substitution we get a meaningful value, then we have to go for substitution. Suppose we got 0 by 0 or infinity by infinity, we have to go for factorization method, right? Next, after factorization, some common terms will be there in numerator and denominator. We have to cancel them, then substitution. So at the end, we have to substitute the limit value in all the problems, right? So now come to third one, rationalization. If problem is in the form of square root of some value minus something, square root of some value plus something, right? Then we will go for rationalization. After that, we did the problems by using our standard limit formulas. After that, if x tends to infinity, how we have to solve the problem. Those are the totally 5 methods. Okay, so now today we will finish with these 4 problems. We will finish our limits. Okay, so come to the first question. What is your first question? So compute limit x tends to 2, x tends to 1 by x minus 2 minus 4 by x square minus 4. If you observe, this is 0 by 0 form. So we will go for factors, taking the LCM and cancelling, right? So how we will do this problem? Limit x tends to 2. So 1 by x minus 2 minus 4 by, how we can write this one? This as x square minus 2 square. A square minus b square form, a plus b into a minus b form, is equal to limit x tends to 2 is equal to 1 by x minus 2 minus 4 by, come on, a plus b into a minus b form. Okay, so is equal to limit x tends to 2, taking the LCM now, x minus 2, x plus 2 is the LCM. Okay, so here x minus 2 is there, x plus 2 is not there, so we have to multiply 1 into x plus 2, right, minus 4. Okay, so is equal to limit x tends to 2, come on, x plus 2 minus 2 is minus 2, x minus 2 by x minus 2 into x plus 2. Okay, x minus 2, x minus 2 cancel. No further simplification is possible. So go for your substitution. That means substitute your limit value. X tends to 2. So 2 plus 2 is equal to 1 by 4 is the answer of your first question. Okay, now come to the second question. What is your second question? Limit x tends to minus infinity. So limit x tends to, sometimes it will be plus infinity, sometimes it can be minus infinity. So 5x cube plus 4 by root of 2x to the power of 4 plus 1. So whenever infinity problem is there, what I said, we have to see higher power term. With that term, we have to divide numerator and denominator. But second value, that means in denominator, values are in terms of square root. First take them outside, then we will decide which term is higher term. Okay, so come on, how we will take the values outside? Limit x tends to minus infinity 5x cube plus 4 by, come on, root of, with this you take x to the power of 4 common, then it is 2 plus 1 by x to the power of 4. Now write separately root, then what happens? Limit x tends to minus infinity 5x cube plus 4 by root x to the power of 4 into root of 2 plus 1 by x to the power of 4. Okay. So then what happens is equal to limit x tends to minus infinity 5x cube plus 4 by root x to the power of 4 means x square, right? Root of 2 plus 1 by x to the power of 4. Now we can compare, right? And we can see which term is having higher power. So x cube is the highest power. So divide the numerator and denominator with x cube. Okay. So then what happens? Limit x tends to minus infinity 5x cube plus 4 by x cube by x square root of 2 plus 1 by x to the power of 4 by x cube. Okay. So then write separately limit x tends to minus infinity 5x cube by x cube 5 plus 4 by x cube. Here x square by x cube 1 by x and root of 2 plus 1 by x to the power of 4. Okay. So if x tends to minus infinity 1 by x tends to 0, 1 by x square tends to 0, similarly 1 by x cube tends to 0, 1 by x to the power of 4 tends to 0. If it is minus infinity or if it is plus infinity, right, x tends to infinity, then 1 by x tends to 0, 1 by x square tends to 0, all those values tends to 0. So if you apply the limits separately, for constant we don't apply the limit. If it is variable, we will apply the limit, right? So here it is 1 by 1 by x, right? If it goes upwards, what happens? Limit x tends to minus infinity, right? X will be there and 5 plus what happens? That value will be 5 plus 0, right? By here it is root 2 plus 0. And what is your x value? It is minus infinity 5 by root 2. So if we multiply any value with infinity, we will get infinity only. Infinity means unlimited, very high value, right? So your answer is minus infinity. Infinity into something is infinity. Remember, already it is minus, so it is minus infinity. Okay. Now come to the third question. What is our third question? Limit x tends to infinity, minus infinity or plus infinity? Minus infinity 2x plus 3 by root of x square minus 1. In this problem also, whenever x tends to infinity, I said compare the higher term in f of x and g of x and divide with that term. But here in the denominator we are having value in square root. So first take out from the square root, then you compare and take your higher term. So how we will write this one? Limit x tends to minus infinity 2x plus 3 by here root of, take x square outside, 1 minus 1 by x square. Then you write root separately for both the terms, right? 2x plus 3 by root x square root of 1 minus 1 by x square. Okay. Then you will have limit x tends to minus infinity 2x plus 3 by root x square is x. Square root will get cancelled by 1 minus 1 by x square. So now x is the highest term. So divide the numerator and denominator with x. So is equal to limit x tends to minus infinity 2x plus 3 by x. Similarly, x into root of 1 minus 1 by x square by x. X cancel, and upwards it is limit x tends to minus infinity, x cancel, 2x by x cancel, plus 3 into 1 by x by root of 1 minus 1 by x square. You know it very well. What is that? If x tends to minus infinity, then 1 by x tends to 0. So what happens? 2 plus 3 into 0 by root of 1 minus 0. So 2 by root 1 is 1. So its value is 2. Okay. Now come to the fourth question. So observe your second and third problems. Your values in denominator are in square root. So actually whenever infinity x tends to infinity is there, we have to observe f of x term, g of x term, the higher order term, with that we have to divide. So whenever it is inside the square root, first take the value x value outside, right, then decide which is the higher order term. Okay, that thing you have to do in solving this second and third problem. Now come to the fourth question. Limit x tends to 0, limit x tends to 0 sine of pi cos square x by x square. So if we go for direct substitution roughly, right, so in f of 0, if we take, what happens? It is sine of pi of cos square 0. So sine of pi of cos 0 is 1. 1 square means 1. So it is sine pi. Sine pi sorry, into 1, that is sine pi. Sine pi can be written as sine 90 plus 90. 90 plus second quadrant sine minus, and ratio also changes, sine changes to cos 90, that is 0. Similarly, g of 0, that is 0 square 0. So we got which form? 0 by 0 form. 0 by 0 form. So whenever it is 0 by 0 form, we can apply L'Hospital rule also, right? If it is 0 by 0 form, we can go for L'Hospital rule. By L'Hospital rule, what is that rule? Rule is limit x tends to 0, f of x by g of x value is equals to limit x tends to 0, f dash x by g dash x. Okay. So instead of limit x tends to 0, f of x by g of x, we can go for limit x tends to 0, f dash x by g dash x. Whenever it is 0 by 0 form, otherwise no need to go for it. By L'Hospital rule, we can take this value. So first you find out your f dash x. So f dash x means d by dx of your f of x. What is your f of x? Numerator, right? Sine of pi cos square x. So come on, d by dx of sine of any value is cos of that value into d by dx of that value, isn't it? So it is a standard formula. Okay, so is equal to cos of pi cos square x. Okay, and d by dx of pi is a constant. D by dx of cos square x is 2 cos x into d by dx of cos x is minus sin x. Okay, so here finally it is minus 2 pi, writing the constants. 2 is a letter, pi is, right? So we can write outside. Then it is cos of pi cos square x into cos x into sin x. Similarly, find out your g dash x d by dx of g of x is x square, that is 2x. So now you take, therefore limit x tends to 0 f of x by g of x is equal to limit x tends to 0 f dash x by g dash x. So limit x tends to 0 f dash x, which value we got it? This one, minus 2 pi cos of pi cos square x into cos x into sin x by g dash x is 2x, 2 to cancel. So now you take negative sign outside and apply the limit separately. Limit x tends to 0, pi also we can take outside, it is a number. Okay, so it is cos of pi cos square x into cos x, and observe I am taking limit x tends to 0 sin x by x. I am giving this x to sin x. We can write a into b by c can be written as a into only b by c. We can write according to situation. If situation demands, we can easily take this value. So come on, is equal to minus pi. Now apply your limit. What is the limit? X tends to 0. Wherever x is there, you take 0 now. So it is cos of pi cos square 0, right, into cos 0. Okay, into limit x tends to 0 sin x by x is equal to 1. Okay, is equal to minus pi into cos of pi cos 0 is 1, 1 square is 1 only, into 1, that is cos pi. Okay, is equal to minus pi into cos pi 180. 180 means 90 plus 90. So minus pi into 90 plus which quadrant? Second quadrant. In second quadrant your cos is minus, and for 90 plus ratio changes, cos changes to sin. So it is sin 90. Okay, so is equal to minus pi into minus, sin 90 value is 1, minus of minus, plus pi into 1 is pi. That is the answer. So this is little bit a special case. By using L'Hospital rule, we solved it. Actually, in other problems also, whenever you get a 0 by 0, infinity by infinity form, undetermined form, you can go for L'Hospital rule, right? So what is L'Hospital? Limit x tends to 0 f of x by g of x can be taken as limit x tends to 0 f dash x by g dash x, right? This is called L'Hospital rule. When it is possible, if it is 0 by 0 or infinity by infinity form, undetermined form, then only we can go for L'Hospital. Otherwise, we cannot go for L'Hospital rule. Okay. So in this problem, your f of x and g of x are 0, 0. So 0 by 0 form. That's why we have taken L'Hospital rule. In other problems also, sometimes we have taken for factorization and we cancelled the common terms in f of x by g of x, then we substituted. That is also one procedure, right? Here factorization is not possible, isn't it? That's why we have taken L'Hospital rule here. Okay. So these are the 4 problems we solved today. With this we complete our limits. Okay, so observe the problems. First one is just we have taken the LCM, we simplified. At the end, no further simplification, we substituted the value. and second and third are limit extends to minus infinity form. So, in such cases we have to compare the above and below higher order term, with that we have to divide the numerator and denominator, then we have to apply the limit if x tends to minus infinity 1 by x square 1 by x cube tends to 0. And fourth problem, we applied L'Hospital rule. Whenever it is 0 by 0 form, we can go for L'Hospital rule. Okay. So, practice these problems perfectly. That's all for today. Have a nice day.